All right, so this is 6.5, which is properties of logarithms, but first up is the ACT. Now, the question in front of you is a 2-second problem for someone who understands matrices. 2 seconds tops. It can be done mentally. Now, the reason it can be done mentally is because they know how you multiply two matrices. To multiply these two matrices together, first off, what you would do is you would check dimensions. You have lost my place here. Rows and columns. This is a 1 by 2, and you're multiplying it by a 2 by 1. That's 2 rows, 1 column. These match, so it's defined. Sometimes you'll see an option down here that says undefined. So, be careful about that, but it is defined. And again, I already did that in my head mentally. You take the first guy, you turn it sideways, you line it up with the second guy, and you're actually doing what we call the dot product in mathematics. But the top is going to be -1 times -2. It's supposed to be a multiplier symbol. The bottom 0 times -1. So the top's going to give you 2, the bottom's going to give you 0, and you're supposed to add those pieces down. I could do that in my head in just a second or two tops. Now, for the rest of y'all, it's a calculator problem. By the way, you're supposed to show work. It legit says show work. All right? The instructions are very clear on this. If you can't remember that, you're going to waste 30 seconds of your life, but you're going to go to second matrix. You're going to scroll over to edit. And you're going to put this is what, 1 row, 2 column? It's a 1 by 2. Got ahead of myself. See how it's already taken me longer? -1, 0 in the first one. You have to quit out. We need to get back and work with some matrices at some point in time. Second matrix, scroll to edit and drop down to B. B has 2 rows, 1 column, and she contains the entries -2 and -1. I remember doing this stuff in 8th grade by hand. I don't remember it being an issue. I quit out. Second matrix A times second matrix B. And I just wasted a minute of my time on the ACT. The calculator is slower, but it gets the right answer. Regardless of how the graph is oriented in the standard XY axis, no graph in one of the following categories has a vertical line of symmetry. Which one is she? Well, that's an interesting idea. Probably the parallelogram or the pentagon. Think about these things. This is the work, by the way. This is the work. Work is thinking and drawing. A line has a vertical line of symmetry because they get cut in half. They run forever. So, square, doesn't matter where you draw it, can be cut in half. My pentagon's not going to be the best it could be. Let's see if I've got the option to draw a pentagon up here. Be nice if I did. There she is. Can I cut a pentagon in half? Does a pentagon have a line of symmetry? Yeah, it's right there. So pentagon's off the menu. I don't like that they wrote parallelogram because a parallelogram can be many things. A parallelogram can be a square, it can be a rectangle, stuff like that. But a parallelogram, if you just think of it like this, Does it have a line of symmetry? But a parallelogram can also be a square or a rectangle. And a rectangle definitely does. It's right there, whatever. So I'm just going to leave it circled. The scalene triangle is probably the right answer. Because if I draw a scalene triangle, that just means, you know, sides don't match. And can I cut that in half? The answer to that's no. So there's going to be a lot of kids who just draw the old 6th grade parallelogram and forget about the lessons they were trying to teach you in geometry. That a parallelogram can be a rectangle, it can be a square, it can be a rhombus. Correct answer to this one is the scalene triangle, K. And I reinforce that by drawing and thinking and extrapolating all that good, useful stuff. All right. The equation 2x squared plus 2x equals 15 has two solutions. What is the greater of the two solutions? I'll show you how to push buttons on this thing. I will. I don't mind pushing buttons, but also remember I teach algebra. So I'm going to move that over there. Usually stuff on the ACT factors. It usually does. Is that equal to 0? Of course, this one may not be too easy. I'm going to guess, based on looking at these denominators, that I'm probably going to be at 6x and a 4x. So I'm kind of looking at those denominators. And 15 is going to be what, 5 and 3? The outside would make 18. Think about that. That's 18x. The inside's 20. And 20 minus 18 is 2. So 20 minus 18 is 2. All right, what are my two solutions? I use that ZPP, the zero product property. 6x plus 5 is nothing. Or 4x minus 3 is nothing. I do the slide and divide technique. X is negative 5, 6, or x is 3/4. That's the greater. See the word greater? You need a subscription hooked on phonics. I got a username and password you can use. Which is the following expression? Oh, I did say I would kind of show you how to cheat in a calculator. You know, don't forget about this, bro. You're going to be holding a TI-84 on that day. We got 24x squared plus 2x equals 15. So 24x to the second plus 2x. Throw a 15 in Y2. Zoom 6. Window. Look up 20 units because we put a 15 in Y2. Hit that graph key. Anyways, sorry I had a text message come through. Second trace 5. Get your cursor close. Enter, enter, enter. Please tell me you understand 0.75 is 3/4. And the other answer here is obviously going to be the lesser. And you see what I'm doing? Like, I'm using a TI-84. A TI-84 graph can solve anything at all. Get close, enter, enter, enter. And there's the other one, negative 0.83333, which is this guy right here. Anyways, there's how you cheat. 42 is something I teach in trig. And you're going to find this kind of funky, but this is actually a geometry standard that no one teaches unless they have a true honors class. Some of you guys have titles of honors, but whatever. A true honors class. But anyways, I teach it in pre-calculus if you take trigonometry. The theorem goes like this. It says that the sine, oh, that's highlighted, not what I want. The sine, usually they use Greek letters, but whatever, the sine of x plus y is going to be the sine of x times the cosine of x plus the cosine of x sine of y. So I kind of notice a lineup process here. This is x, this is y. I'm actually looking at the sine of 60 plus 30. You had to know a formula, as this one. So here's your work, you know. Now here's how you cheat. These are degrees. See those degree symbols? The TI-84 you have on test day will not be in degree mode. It'll be in radian mode. You put your calculator in degree mode. Press enter. You quit out. You type in sine 60, cosine 30. Notice I'm closing parentheses too. And you're probably not playing along. You're that particular kid. I get it. You're not going to college. What's any of this matter? I get it. You don't know your future yet. He gets 1. Now, I think it's J. So I type J in. J was the cosine of 60 plus 90, or 60 plus 30, which is the cosine of 90, which I know by heart at this point in my life. Sorry, it was sine. I typed cosine. Oops. Even I'm not perfect. Ta-da! There you go. 43. What is the area in square units of a circle that has a circumference that is 12 pi units long? So I happen to know that circumference is twice pi r. And I happen to know that's the circumference of the circle, by the way. I happen to know the area of the circle is pi r squared. Most of my junior class does not. This is an easy problem, and you won't be able to do it. And I'm sure it's somebody else's fault. But whatever. The circumference is 12 pi. I do substitution. It must be twice pi r. I divide out twice pi. And my radius is, what, 6? You know, if you can't do that, you type in 12 pi. Be careful how you do it, too. Don't do divided by 2 pi like this. You hadn't learned a single thing in high school. You do 12 pi divided by parentheses 2 pi. Somebody showed you that once upon a time. 6. Shame on you, though, for needing a calculator. And anyways, you take your 6 and you throw it right there. So the area of your circle is pi times a 6 squared, which is going to be 36 pi square units. I don't even care about that. Choice D. Ta-da! All right, on to the actual lesson. Actually, let me stop that so this video is not so long. Actually, I'm just going to keep going. I have a new laptop now. I don't care how big the file gets. Bums. All right, first one in here is to rewrite, and I was very kind. I gave you properties of logarithms. And here's a property. Notice that divisor symbol? You're dividing by z, and notice we take away that one. And the deal here is when condensing positive logs positive arguments stay in the numerator, and negative arguments go to the denominator. That's the key to it. And that's what that rule is trying to explain. Let's chunk this out the window. You do have to understand understood symbols, like you ought to know that that is a plus sign there. If I can type, that's a positive log. The condensing is going to be 6/2. Subtraction, division. See it? Which reduces down to the natural log of 3. Number 3 is 2ln6, and if you look over here, you'll see the rule for it. You just follow a rule. It's all you do. It says that the 2 becomes an exponent. So this becomes the natural log of 6 squared, which is the natural log of 36. This little group right here is the type of logarithm questioning that was on the ACT when I was a kid. When I took it back in 97, you know, the time before. It was a long time ago. And it's about having good number sense. That's the reality of it. You have to have number sense. Plain and simple. And here's what I mean by that. When I look at number 5, I have log of 64. I tried to get y'all guys to get some number sense, but you just wouldn't do it. I see a 4 cubed, because 4 times 4 times 4 is 64. Then I see this property up here. It becomes 3 logs of 4. And then I look up here. This becomes 3 times 0.602, which is going to be 1.806. You feel free to check me. Like, I know some kids get confused when I do math in my head. Like, just check me. 3 times 0.602. I didn't do magic. I just computed numbers. That's all I did. All right, 6 is the log of 1/3. And when I look at this one, what pops into my head is this condensing idea up here. I see a division. I'm thinking about negativity. That's what I'm thinking about. So I'm going to rewrite this as a log of 1 minus a log of 3. And that might not actually be the best way to do that. Actually, forgive that. Here's your numbers, 4 and 12. I should have just done that. There's my numbers, 4/12. I happen to know that 4/12 is 1/3. So I'm viewing this as a log of, and I would have gotten there sooner or later, log of 4/12. And now let me do this break apart rule. Log 4 minus log 12. Log 4 is 0.602, or 602 thousandths. And I'm taking away log 12, which is 1 79 thousandths. And what's that going to give you? Negative 0.4. I always kind of screw these up. 77. That should be checked. So let's just see if I'm right. I'd hate to do something wrong. Yep, there we go. Good. All right, moving forward. Condense the expression into a single logarithm. All right, first things first. You express your factors, which are the numbers out front, as exponents. That's what I'm going to do first. I'm also going to convert to fractions. So this guy is going to get moved up top. He's going to move there. He's going to move there. She's going to move there. This becomes the natural log of all of 2y to the 1/2 power, not just part of it, plus the natural log of all of x squared minus, I'm not moving the negativity, so you could, minus the natural log of all of z cubed. Now it's time for condensing. And again, I'm going to write this down. I just wrote it down. When condensing, positive logs have their arguments placed in the numerator, and negative logs have their arguments placed in the denominator. That's the deal. So let's do some condensing here. I'm going to have a singular natural log. I'm going to switch over to brackets. It's going to have a numerator and denominator. The numerator is going to contain all of 2y to the 1/2. It's going to contain an x that is squared. You can drop the parentheses. And this one's negative, so the bottom z cubed. Ta-da! More magic. Moving forward. It's an expansion. And we're going to kind of follow these same ideas that we did on the condensing. So when expanding numerators, let me rephrase that, arguments of the numerator become arguments of positive logs, and arguments of the denominator become negative logs. I cannot give you any better, clearer instruction than those words. Can't do it. I think part of the issue is kids have no idea what it means to condense and expand. I just don't know what's going on in y'all's head. 13, we happen to have one of those understood logarithms. Where was I? Oh, yeah. I need my cursor. I have a log, and you could break this up in several pieces, of 6 plus a log of x squared minus a log of y to the 4th. Now, you'll notice it has this little statement in here to express powers as factors. So after the initial expansion, move the exponents out front. And pay attention that I broke that thing up because 6 did not have a 2. Did it? It didn't. So we have a log of 6. We have 2 logs of x, and we're taking away 4 logs of y. And that's the complete expansion of number 13. So moving on with my life to 14. 14 is log base 3 root 9x of z. The same rules apply. You do need to understand that a root of 9x is, and think about this, the understood 2 all to the first, 9x to the 1/2. Because remember your x to the p over r notation. X to the power of a root is the rth root of x to the p, or the rth root of x all to the p. So that's a kicker on this one. And I need parentheses there. Don't forget about this. Don't forget to wrap. So let's do my initial expansion. I have a logarithm of base 3. Inside her is 9x to the 1/2. That's all I see. I could actually break it apart a little more. It's actually worth doing. Log base 3 of 9 plus, sorry, that's still to the 1/2, plus log base 3 of x to the 1/2. And this one's negative. It's down in the denominator. So minus log base 3 of z. Now, here's the reason I broke this apart. I have a log base 3. 9 to the 1/2 is literally 3. And log base 3 of 3, you're supposed to think, what power of 3 is 3? And the answer to that's 1. So 1 plus log base 3 of x to the 1/2 minus log base 3 of z. Final answer, because Milbrath said so. That's what you're here to learn. Not necessarily Algebra 2, but what Milbrath says is right. If I make a mistake, catch it. It won't be anything too big. This used to be an Algebra 2 standard, and it was pulled. Like, this legit used to be an Algebra 2 standard. It is a 6,000 plus year old technique given to us by the Babylonians. If you have no idea who the Babylonians are, you obviously suck at history. And it is still kinda an ACT standard. Very rare it shows up that you need to know it, but the ACT has circles. And since the ACT has circles, you're supposed to know how to complete the square. Anyways, I left the instructions in here, and you've got all the steps off here. First step is to divide all terms by a. So I'm going to go through and do my division. Come on, get out. I keep trying to use my finger on this drawing pad, and it just don't work. It'd be a lot cool if it did. I'm going to divide everything by a, -4. It'll give me x squared minus 6x equal to -4. Here's step 2, move the constant to the right-hand side, and that's already done. Step 3 is to take half of b. So b is a -6x. If I cut it in half, I get a -3x. Square it, I get 9x squared, and add it to, sorry, b is not b is just -6. I got off on somewhere else. I was doing a problem the other day where you had to include the variable. Sometimes I find very difficult math problems, and I legit solve them because I'm just curious to see if I still have it. And so when I square -3, I get 9. And that 9 gets added to both sides. Now, this thing is what we call a perfect square. It factors as x minus 3 times x minus 3. And -4 and 9 makes 5. If you're going to write something twice, it may as well just be squared. Oh, by the way, also pay attention to this. I don't teach this like I need to. I'll probably bring it back next year. I really want to teach this next year. So next year's group's going to be taught it. I didn't like leaving it out. What's it say? Counteracts squaring by square rooting. So I take the square root of both sides. I include the plus or minus symbol. I have no idea what the root of 5 is. I don't care what it is. The square and the square root knock each other out, because remember there's that understood 2. Think about your x to the 2 over 2 is just x. That kind of funky notation. And there's an equal to symbol, and I move my 3 over. And x is 3 plus or minus root 5. The quadratic formula was created because they thought to complete the square method was too hard for the average person. So that's why the quadratic formula was made. 18, which is hopefully the last one I need to do because I'm really getting tired. Solve this inequality. And I gave you instructions. Like I said, if you need a subscription hooked on phonics, just hit me up. Let's say it says isolate the radical first completely. You must even divide out the negativity within the radical. So that's where we'll start. I'm going to subtract 2. And a -4 minus 2 is -6. Now I'm going to divide out the negativity. And that'll give me the absolute value of 2x minus 3 less than or equal to -3x plus 6. And now I'm going to write 2 equations. One of them is as is. And the other one, you can either change this or you can change that. It doesn't actually matter. Mathematically, you're supposed to change this. But it turns out it doesn't matter which side you do. So I'm just going to change this like I'm supposed to. Or -2x plus 3. The ACT wants you to change this. ACT says change this. Less than or equal to -3x plus 6. And then you solve, and you just do basic algebra. I mean, you move that guy over there. 2x plus 3x is 5x. 6 plus 3 is 9. Divide out the 5. X is less than or equal to 9/5. Or, same technique, -2x plus 3x is x. 6 minus 3 is 3. So, 2 answers. And that's 18. You are supposed to plug in and make sure they work. I'm confident moving forward in my life. And the last one I'm doing, it says let f of x equal 2x, -2x to the second, and g of x equal 2x minus 4. On the set of axes below, draw the graphs of y equals f of x and y equals g of x. You're supposed to know what -2x squared looks like. -2x squared has vertex at 0, 0, and initial slope -2, and it looks like a U. In this case, it's upside down because of the negativity. Now, one thing I might do on this one is I might actually make a small table of values. But that's my initial slope. Let's see what happens if we plug in a 2 or a -2. I plug in a 2, I'd have -2 times 2 squared, which is -8. And the same thing would happen because of symmetry here. A -2 squared is 4. 4 times -2 is -8. And those are worth plotting. I'm solving by graphing, which means I want every point that I could possibly have. I'm also supposed to graph 2x minus 4. That is legit mx plus b. It crosses the y-axis at -4. And then it rises 2 and runs 1. It also falls 2 and runs 1. Falls 2 and runs 1. Notice all the points I plotted. There's a reason I plotted so many points. These little points are supposed to be here and here, weren't they? I put those in the wrong spot. Evidently, I can't count. Oh, that's supposed to be there. I can't count. I just can't draw. And I just crashed my software. Wonderful. Oh, that's annoying. Give me a second. Yes, please do recover that flip chart. Where was I? Oh yeah, I was kind of correcting some stuff here. It can't go back. I kind of drew that a little bit wrong there. I missed some points. And I can't go back and erase now since the software crashed. But anyways, I can fix it. It was supposed to look like this. And I apologize. They want to know where these two things are equal, and that's the intersections. And they only want to know the values of x. So this is true right there where x is -2. And it's also true where x is 1. And those are your answers. Sorry it crashed at the very end. But finally done with this video. It's taken most of my planning period. I tried to go slow and I tried to be nice. I'm being the best person I can be right now.